Nitric acid is considered a monoprotic acid because it can give away one proton to form one hydronium like this. Sulfuric acid we would normally write as H2SO4, but that really means that it's a sulfate with two hydrogens. So we could also write it as HHSO4, and that will help us to see why it's a polyprotic acid. Polyprotic acids are acids which can react with water more than once to form more than one hydronium, right? Poly meaning many. So what the sulfuric acid can do is it can react with water one time to form one hydronium molecule like this. And that will leave behind the hydrogen sulfate ion. And then this hydronium can go and float off into the solution. But there's going to be more water around, and this hydrogen sulfate ion still has a hydrogen that it can get rid of here. So what this guy can do is it can react with water again, transfer another hydrogen ion over to the water to form a second hydronium, and leaving behind the sulfate ion. So sulfuric acid then is a polyprotic acid because it can react more than once to produce multiple hydroniums. We can show those same steps here, starting with my sulfuric acid, reacting with water to form hydronium and the hydrogen sulfate ion. And then I can recognize that this thing can react again because it still has a hydrogen it can give away. So then the hydrogen sulfate ion, it can go and it's going to form my reactant for the next reaction. Because as long as there's still water floating around, this hydrogen sulfate ion can potentially react again. HSO4- can react again to form another hydronium, leaving behind the sulfate ion. Now, how can I recognize that this thing the sulfate ion can't go on to react again? Well, it has to be able to give another proton, another H+, to water if it's going to be able to react again. And because there are no more hydrogens left, that means that this thing can't go on to react a third time. And likewise then, a polyprotic base can react more than one time to produce two or more hydroxide ions. So if I have the carbonate ion here, it can act as a polyprotic base. Remember, bases are things which react with water to form hydroxide. So this guy is going to steal a hydrogen, form the hydrogen carbonate ion, and a hydroxide ion. And then a good sign that this guy can go on to react again is he's got a negative charge. And chemical entities which have a negative charge are typically going, not always, but are typically going to be pretty happy to steal a hydrogen from water. So my hydrogen carbonate then can go on to react a second time with another water molecule to steal another hydrogen to form H2CO3. Now, whether you have a polyprotic acid or a polyprotic base, the percentage to which each successive reaction happen is going to drop substantially. So the carbonate ion here is an okay base. It's not a bad base. But the hydrogen carbonate here is going to be a substantially worse base. Same thing is true for my polyprotic acid. The sulfuric acid, H2SO4, is a good acid, but this hydrogen sulfate ion is going to be a worse acid than the original one. And each time I go down a successive step, the reaction happens to a smaller percentage. Amphiprotic substances are kind of like amphibious vehicles. An amphibious car can be a car and it can be a boat. An amphiprotic substance can be an acid or it can be a base. It can act as both. A good example is the hydrogen carbonate ion. We can show hydrogen carbonate acting as an acid, transferring a proton to the water molecule to form carbonate and hydronium, And I know that this is acting as an acid because I have it producing hydronium. But it can also act as a base. Because the hydrogen carbonate ion has got a negative charge, it's also going to be happy to take a hydrogen from water. So it could also do this. It could react with water, steal a hydrogen away, forming H2CO3 and hydroxide. And I know I have it acting as a base here because I formed hydroxide. Now the logical question is, which is it going to act as? Is it going to act as an acid or a base? And that's a higher level topic that we won't answer here. So for now, we would have to tell you whether it's going to act as an acid or a base. But the things you want to look for, in order to act as an acid, it has to have a hydrogen ion it can give away. So we have that here. We have a hydrogen ion we can give away, which means it could act as an acid. But it also has a negative charge, which means it's also going to be happy to take a hydrogen away.